Salo, I think that we can start.
Okay.
So, welcome everybody to the closing session of this cycle of our seminar, Débat sur le débat. It's a real pleasure to be with you tonight, and even a greater pleasure to welcome our guest, Susan Herring. So Susan Herring is professor of information science and linguistics and director of the Center for Computer Mediated Communication at the Indiana University, Bloomington. For the past 35 years, she has been at the forefront of research into the structural, pragmatic interaction and social dimension of digitally mediated communication. Her most recent work has focused on multimodal CMC, examining how we communicate via telepresence robots, graphical icons, and videos. A particular interest of hers is digital face modification and discourse surrounding deepfakes. Susan is also known for her editorial contributions. She was formerly the editor of the Journal of Computer Mediated Communication, and she currently edits Language at Internet. So before handing over to her, I'd like to briefly highlight a central outcome of her broader body of work, namely the establishment and development of the theoretical and methodological framework known as computer-mediated discourse analysis, CMDA. CMDA emerges from decades of inquiry, and it rests on three core assumptions. Susan, you can correct me if I'm not well representing your ideas. Two of these assumptions stem from critical discourse analysis, namely the fact that discourse exhibits recurring patterns and the fact that discourse involves speaker choices. The third assumption is that computer-mediated discourse may be, but it's not necessarily shaped by the technological affordances of the platforms on which it occurs. And grounded in this principle, CMDA draws upon methodologies from conversational analysis, from interactional social linguistics, pragmatics, text analysis, critical discourse analysis. And this approach has generated studies that have to better understand the profound transformation that computer-mediated communication imposes on our ways of interacting, our ways of communicating, and I think our ways of speaking. And what is particularly interesting for us is that computer-mediated discourse analysis also focus on the challenges that these transformations presents for linguists. For linguists, I'm sorry. I'm sorry. I think that we need to couper le son. Okay. For the challenges that this transformation presents for the linguists who seek to make sense of that. So thank you, Suzette, for all this work. And thank you for being here with us tonight. I mean, tonight for us, but this morning for you. This is not, I think, the most convenient hour to deliver a seminar in the USA. So we are very grateful for your effort. And we are very happy to listen to your new research on a topic that concerns all of us, and it's becoming central here in Lille. Beside our work in the Observatory Hollandinum, but within the framework of a working group on that tries to answer to the question, what is artificial intelligence doing to our profession and our research practices? I think that your tonight talk is at the core of this question. So thank you again. We are truly looking forward to hearing your reflection, the compelling question that gives today's talk, whose title is Generative AI the future of qualitative discourse analysis? The floor is yours. Thank you very much.
Thank you, Paula, so much for inviting me to give this presentation, the final presentation of the series hosted by Olen Dinum. And thank you for that very useful introduction because you laid out some of the groundwork that this talk will be building on, and that really was saves me some effort. Um, so I should say, first of all, that I am not a specialist or an expert in artificial intelligence. And by the way, we say in English, of course, artificial intelligence, AI. In French, it's
Yeah.
IA, right? Um, but I'm actually a discourse analyst. As Paula said, I teach research and teach in computer-mediated discourse analysis in particular. But I also teach in a school with a strong AI focus. And so I've been thinking about the intersection of AI with the kind of work that I do, much of which is qualitative and involves manual analysis of data, particularly of online data. So what follows here, and that I'm going to talk to you about today, is very, very preliminary research that I've been working on with 3 PhD students at Indiana University about the integration of generative AI into computer-mediated discourse analysis. And one of the questions that we ask is, the core question really is, can CMDA be analyzed by artificial intelligence? And if so, how well can it do it? And in concluding, I'll consider both positive and negative effects of AI on the field of discourse analysis rather broadly and advance some recommendations. The talk is organized into 3 main sections. I'll first talk a little bit about computer-mediated discourse analysis. Then I'll talk a little bit about generative AI and specifically large language models or LLMs. And then I'll present the study. So we have the main research question, can LLMs do CMDA? If so, how well? The focus of what we've done so far has been on 2 CMDA methods, speech acts or CMC acts, as they're called in CMDA, and a politeness analysis. And so I'll tell you about the data, the methods we've used, and some of our very preliminary findings, and then conclude with some future thoughts. So to start with, CMDA is, I don't like to call it a theory. I think of it more as a toolkit for analyzing digitally mediated language and language use using methods of discourse analysis broadly construed, methods that come mainly from linguistics, but also from psychology and communication to a certain extent. It is a language and discourse focused approach to analyzing computer mediated communication. And it was developed primarily for textual CMC back in the late 1990s and early aughts. And then more recently, I've expanded it to include multimodal CMC. It is primarily a descriptive and interpretive approach. Um, and the toolkit is organized around 4 levels of linguistic analysis. And the levels are structure, meaning, interaction management, and social phenomena. And this chart here just sort of summarizes the toolkit by listing some of the phenomena that one might be looking at, the issues that one might be interested in studying, and the methods that one might draw upon to address those issues, looking at those particular phenomena. And I'm not going to go through the whole set of four levels. I'm just going to tell you about two levels, the level of meaning, which includes speech acts. And so here we might be interested in what the speaker intends by what they say, or what is accomplished through their choice of language, and drawing on methods, for example, such as linguistic pragmatics. The fourth level is also relevant to my talk today, a level of social phenomena, and particularly with politeness, we're interested in face management, which we can talk about in terms of social dynamics, power, and so forth, using methods such as interactional sociolinguistics or critical discourse analysis. I'm actually going to be drawing primarily on linguistic pragmatics to study politeness. Now, CMDA typically takes place on a small scale. The analysis is done mostly manually, and when I teach this to students, they look at small data samples, um, which is appropriate in discourse analysis because the phenomena of interest are often nuanced or complex, and they are not easily reducible to structures or lexical items that would lend themselves to large-scale automated analysis. And so, for example, we can think of phenomena like the mechanisms of humor in discourse, interactional dynamics, and the multimodal construction of meaning. Uh, and for all of these phenomena, the information that is of interest to the analyst must often be inferred from the context. Uh, so these are also contextually situated kinds of analyses. Uh, so now I move to tell you about a course that I teach. It's Z641, Computer Mediated Discourse Analysis. And the students in this class are master students or PhD students, so they're postgraduate students. It is a research methods course, considered an advanced research methods course. And I say this because I want to say something later on about the level of sophistication of the students. These are pretty sophisticated students. However, they are not, for the most part, linguists, so they don't have a background in linguistics. And in this course, I present the techniques and certain tools for analyzing computer-mediated discourse at each of the four levels, focusing on one topic per level and typically one tool that I present per level. The students then apply the methods to what I call a sample of approximately 200 messages, and they present their findings orally and in written reports. So that's the structure of the class. So now I'm going to tell you about two CMDA methods, ACT analysis, CMC ACT analysis, and politeness analysis. And I chose these two to focus on because both have been studied quite a bit in discourse pragmatic research over the years. They both also have a subjective interpretive component, as does most of CMDA, but at the same time, they both have coding schemes that have been validated over many studies, over many years. Um, I've been teaching this course for over 25 years, for example. And these coding schemes lend themselves to quantification, making these methods potentially easier for AI as a computer to process than some other CMDA methods that may be more complex. So on the one hand, these have a subjective interpretive component, which might make it more challenging for an AI to understand them, but they also have these coding schemes that can be operationalized in more, um, I want to say almost in structural terms that can be analyzed quantitatively. So I'm going to introduce each method similarly to the way that I would present it to my CMDA students, and then identify the challenges that students and other human coders, including myself, often encounter in applying the methods, due in part to the inherent subjectivity that is part of the methods. The purpose of telling you a lot about these methods now is to establish a basis for comparison with our AI analysis later on. So to start with, the first level is the level of meaning analysis and specifically CMC acts. And in this exercise that the students do, the goal is to identify, classify, and interpret illocutionary acts in computer-mediated discourse in a sample that they have chosen. And in this sample, the messages are typically in chronological and or threaded order in order to preserve the immediately preceding and following context. And we use a tool that I developed called the CMC Act taxonomy. And this is a basically a speech act taxonomy that was created by consolidating acts from a bunch of different speech act technologies that are taxonomies that are available in the literature. And it has 18 acts, including things like inquire, direct, claim, inform, accept, thank, and so forth. And it also has two meta acts, self versus reported information and bona fide versus non-bona fide communication. So I'll tell you a little bit more about all of these. This is a summary of the CMC Act taxonomy. These are the 18 acts. And what the students actually see is if I can go and show you this, can you see this web page that I just pulled up? Is
Cannot
that
see a web page. We see a table.
no? Okay. So you don't see the web page. That's okay.
Not that this.
You don't need to see it. Just to point out that um, there is a web page. Now I have to go back and find my slides here.
Now it's okay.
There.
We could see the web page
Uh,
when you narrow down the screen.
okay, let's see. Well, it's can you see it now?
Not the web page, the table.
Okay. All right. Well,
Now it's
there
okay.
anyway,
Okay.
the link is there. It's not important. So the link is there. And in the on the web page, you have the categories, but also their operational definitions and examples. So this is available online, but also what's used to teach the students what is intended by each of these acts. One thing I'll say about the acts is that there are certain ones that are tend to be far more common than others. For example, inform and claim are very common acts. Inquire also is quite common. It depends on the nature of the discourse, of course. Some discourses you'll have a lot of direct acts, imperatives telling people to do things. And desire acts are also fairly common because it's a broad umbrella category of irreal situations. But some of the others are much less frequent. For example, thanking and managing the discourse, behaving, actually performing actions through words is much less common. Elaborate, these are less common acts. And that's going to be somewhat relevant when we see how the AI interprets this. Then here are the meta acts. So we have the self-perspective versus reported perspective. And most messages by default are self-perspective. That is to say, the people are saying things in their messages that represent their own perspective. But occasionally we have reported perspective, as in the example here. The president said that he wants to bring peace to the Middle East. So the he wants to bring peace to the Middle East is a desire act. It refers to a future desired situation. And it is reported perspective. It is the perspective of the president, not the person who is reporting that the president said this. Another type of meta act is the bona fide versus non-bona fide communication. The default is bona fide, which is we assume that most people are sincere in communicating whatever it is that they appear to be communicating. But non-bona fide communication appears often with irony, sarcasm, and humor. Somebody appears to be writing on my slide. I'm not sure how that happens.
I
Uh,
know he is, but I, I want to say, can I say, Isabella, fai attenzione perché stai scrivendo sullo schermo di Susan. So, okay, it's okay. I saw who did it, but
okay. All
I'm sorry.
right, good. Okay. Now is it on all the slides? So, um, now I want to talk about some challenges for ACT analysis that students and other people come up against very often. The first is that the desire code is actually an umbrella that encompasses four different kinds of meanings. Wants, hopes, and wishes, as one might expect for desire, but also promises, predictions, and speculations about the future, and hypothetical and counterfactual situations. And what these have in common is that they are all irrealis, but because my students aren't linguists, they don't understand what irrealis is, that concept. So we give it this name desire, but emphasize that there are other things that are included underneath it. Human coders most often fail to include hypothetical and counterfactual messages under the Desire Act as a common uh, error. Another challenge is how deeply one should interpret a message sender's intention. And we can imagine here a kind of an arrow going from surface to deep, where you have the surface form of the message, the language that's used, a little deeper, we have the conventional illocutionary force of the message, which might differ from the surface form. A little deeper beyond that, we might say that there could be an illocutionary force that is suggested by the discourse context, the messages that come immediately before or after. Also, there could be another illocutionary force suggested by the discourse external context, for example, the broader political situation or the discourses about AI in general. And then finally, at the deepest level, and I generally warn my students not to go this deep. There may be meanings that are suggested by how you interpret the message producer's psychology or underlying motives. And I can give you an example of how these levels of interpretation can actually affect what act you would ascribe to an utterance with this example here that comes from another study that I'm doing where I'm looking at comment threads where people respond on social media about deepfake videos. And so here somebody has commented, "Welcome to the Matrix." The Matrix is a movie, which some of you may be familiar with. It's a science fiction movie. And so if you, it's helpful to know that. So on the surface form, this welcome, I welcome you, is a greet action. You know, I'm greeting you. But conventionally, it's also an illocution, has the illocutionary force of an invitation. If I say, "Welcome to my home," I'm effectively inviting you to come into my home. Um, but in the discourse context, where they're responding to this deep fake, which many people find unnerving or even frightening, it's a claim because it means something like it's like we're in the movie The Matrix, or this AI, this deep fake is like science fiction. So that's a claim. And if we go further into the psychology, we might say that it actually is communicating something like AI is dangerous or AI is scary, which would also be a claim. So it does matter what level you choose to interpret at. Another challenge is we have challenges with how to apply the meta-act codes. The non-bona fide meta-act code, this could be for jokes, rhetorical questions, what I call compassionate non-apologies when you say, "I'm so sorry your mother is ill," right? I'm not blaming myself for it, but I'm showing compassion towards you, and some sarcasm, irony, and teasing, and so forth. All of these could be coded either as the surface act plus the indication NBF for non-bona fide, or for the underlying pragmatic meaning as we were just talking about with the levels. So for example, Here's another sentence from those threads about deep fakes. Somebody posted, "Have we really become so sensitive we're unable to just look at other human beings as they are?" This is a rhetorical question, right? So what they're really saying is something like, we shouldn't be so sensitive that we can't just look at other human beings as they really are. But on the surface, it's an inquire. It's asking a question. It's a non-bona fide inquire. This is a characteristic of rhetorical questions. We could also analyze it as a claim, though. We should not be that sensitive. So there's always that possibility, doing it more than one way. Uh, the problem is we have a similar problem on the one hand, but also a different problem with the Meta Act code of reported perspective. And here you could code it as what the surface form of the reported speech is. And so in the examples that I'm going to show you, and these are made up examples, consider the first one, direct speech. Maria said, "I will call Pierre." All right, so I will call Pierre. This is a future action. Therefore, it's a desire act, but it's reported perspective. It's the perspective of Maria, not the perspective of the person who is reporting that Maria said this, right? So we could always code these in two ways. We could also say that Maria said, "I will call Pierre," is an inform act, that I'm simply informing you that Maria said that. And whether you want to code it as an inform or whether you want to code it as a reported desire act will depend on what you think is most important in the discourse context. But another problem that we have here is that there are degrees of directness, degrees that where there's no clear line between what would be included as reported perspective and what would not. And so, for example, in direct speech, Maria said that she would call Pierre, still that she would call Pierre as the reported desire act. Free and direct speech, even as we might encounter in a narrative, literary narrative, she would call Pierre, Maria decided. Again, she would call Pierre as still a desire reported perspective. But what about with non-speech verbs, such as Maria obviously wanted to call Pierre? So it would be possible to code in example number 4 as also a reported desire act. But people are less likely to do so than they are for the other more direct acts. Okay. The second uh, method is politeness analysis, and this is at the level of social phenomena. And the goal here is to have, when I teach this, to have my students characterize the politeness of utterances in the context in which they occur and in discourses overall. They look at messages in chronological and or threaded order, again, to preserve context. And we use a tool uh, which I adapted uh, from the classical work on politeness by Brown and Levinson in 1987, where I classify violations of positive and negative politeness and observations of positive and negative politeness, which I'll show you in a minute. And I also want to emphasize, and I emphasize to my students, that not every utterance expresses politeness. Some are neutral or indifferent as regards politeness. And so those should not be coded. So coding is selective in this case rather than exhaustive, and that poses a challenge. So here's the politeness coding scheme. We have 4 codes. It's a very simple coding scheme, plus P and plus N, which are observations of positive and negative politeness, respectively, and minus P and minus N, which are violations of positive and negative politeness. And I'll have to say that P tends to be more common than N, particularly in the discourse I'm going to show you today. So plus P would be, for example, compliments, approval, showing support towards the addressee, including the addressee could also include friendly joking, friendly greetings. Minus P would be kind of the opposite of that. Insults, bald challenges, bald disagreements, sarcasm, or jokes that are targeted against another person. Whereas negative politeness observations would be respecting the other person's point of view, maybe hedging a request that might otherwise be an imposition, offering choices, apologizing. Pre-inquiries can also be part of negative politeness. Violations of negative politeness would be insensitivity to another person's time, overriding another person's preferences, not acknowledging another person's preferences, making imposing requests or commands, imposing commands. So we give these examples and we give the coding scheme, and then they practice doing it. And one of the challenges for politeness analysis is that I tell the students, do not code face threats or face payment to someone who is not part of the thread or likely to read the thread. In other words, um, the face you're managing through politeness, you're managing the face of an addressee, but that should be somebody who has face in the game, so to speak, who has face in the discourse that you're analyzing. So in this example here, um, what an insult to charge you with murder after what this sack of shit has done. Here, the sack of shit refers to a murdered man, but he's dead and he's definitely not in this thread. So, in fact, this is not an insult to anybody. It's actually, I'll show you later, it's actually an observation of positive politeness. But then what about this example and from the same thread that I'm going to talk about today? I'm guessing these assholes who don't care to hear it also didn't care about the abuse that he dished out and that caused his death. So here, assholes refers to the murdered man's family. Uh, when I read the thread, I thought that the family probably was not reading it, but it's possible that his family members, the murdered man's family members, may read this thread. It's a public thread, in which case their face could potentially be threatened by being called assholes. So this could be coded as a minus P under that assumption. And then it's also possible that some people could be offended by the use of profanity, even if their faces are not being directly otherwise threatened. And that could be coded as a minus P, even when the target is absent. So these are, again, decisions that the analyst has to make. Two more challenges for politeness analysis. Um, First is how to classify utterances that could be classified as either plus P or minus N. And that might sound strange. How could they be both a plus and a minus? But an example that's quite common is advice. Advice can be unsolicited and it can be potentially unwelcome. So I made up this example here. You should take better care of your precious self. On the one hand, you should take better care of yourself is minus N because it's basically telling the addressee what to do and could be unwelcome, as I said. But then your precious self and the fact that maybe the speaker is intending to show concern and support for the addressee could be coded as plus P, and the context is going to determine which would be more appropriate. And finally, the last challenge for politeness analysis. What if you have an utterance that performs more than one kind of politeness? And this occurs quite often with plus N and minus P. So for example, I hear what you're saying, but it's wrong. Where you have, I hear what you're saying is plus N, acknowledging the other's point of view, but it's wrong. Bald disagreement, minus P. Or I think you just don't understand, and that's fine. So here, I think you just don't understand. Minus P, you're not getting it. You're obtuse. But that's fine. You do you, right? Plus N, that's okay. One solution here is you could divide these into two utterances and code them separately. But that's something that you sort of figure out as you're doing the coding rather than before. So the problem does come up quite a bit. So how do we overcome these challenges in CMDA? We look for two things. On the one hand, consistency of interpretation of the codes and plausibility of the coding according to the context in which the discourse occurs. So this is what we strive for: interpretive consistency, contextual plausibility. Okay, we move now to generative AI. And just a couple of words of background about generative AI. Uh, it uses machine learning algorithms and intense learning to learn patterns in data and generate new plausible versions of that data. Um, it can include text, images, or other types of data that can be generated. Um, so we have generative AI models such as DALL-E, ChatGPT-4, and Stable Diffusion have successfully created realistic and sometimes convincing outputs. Say convincing in the sense that you can't tell the difference between those and human-generated outputs. And what I want to focus on here is the potential of generative AI with regard to CMDA or discourse analysis in general. Um, and so first of all, we have large language models or LLMs. Um, you may know some of these. I think we have different ones in Europe than are used primarily in the United States. So I mention here OpenAI's ChatGPT models. We have now we have GPT 4.0, GPT 0.3, and earlier models, of course. Meta's Llama and a Mistral, which is a European model, can generate summaries, extract key topics, rewrite complex content to make it more understandable and other nifty things. It can be fine-tuned to classify discourse types or perform entity recognition, which can be used to label large corpora of online communication data or large corpora of any data, as long as you have it in textual form. Moreover, many platforms offer apps and interfaces that don't require deep technical knowledge. You can just type in a prompt and then refine your prompt, and it generates an output. The potential for these tools is increasingly being recognized in interdisciplinary research, so including, as I say, in my field. Now, a caution that is always advanced with regard generative AI is that the generative AI tools can hallucinate. And this is a technical term. It means that they generate outputs that seem plausible, but are not accurate or grounded in reality. Um, Now, that said, hallucination rates have been generally declining with more advanced AI models. So, for example, GPT 4.0 has a relatively small hallucination rate. I saw something that estimated it to be around 1.7%, which is really small. But advanced reasoning models such as GPT-03 and the Chinese LLM DeepSeek which attempt to think through problems step by step, are particularly prone to hallucinations, possibly due to their complex reasoning processes. Thus, there is a need to ensure accuracy and reliability of AI-generated content. Okay, so now let me tell you about the study that we've been working on. And this is very preliminary work. We have plans to expand this in other directions. I'll tell you about that later if we have time. But for now, what we have looked at is one Reddit thread. It has 257 um, utterances slash messages. I say utterances slash messages because if you're familiar with Reddit at all, you know that very often there will be what's called the original post or the OP, and then people will respond to it. And this thread comes from a subreddit called Ask Me Anything, and it's about young people who have spent time in jail and come out of jail, and they talk about their experiences being incarcerated. And so you'll have typically an original post, which is telling their story, and then you'll have short, comments, question and answer afterwards. So in this particular thread that we're looking at, there was a young man who, at the age of 14, shot and killed his mother's abusive boyfriend. The boyfriend was also being violent and abusive towards his little sister, whom he felt very protective of. And so he killed him. He went to jail. He was in juvenile incarceration for 7 years until he was turned 21. So he tells his story. And what we did is we manually coded this thread for both CMC acts and politeness. And this was done by myself and a PhD student who who had taken the course, the Z641 CMDA course that I teach, so was familiar with the methods already. Um, I'm not going to be able to show you the prompt, I don't think, because it's on the web, but there is the link here. So what we did is we generated act analysis and politeness analysis using two versions of ChatGPT. ChatGPT 4.0, which is the basic model for general use, and ChatGPT o3, which is a newer model that's been optimized for programming and mathematical reasoning for, analytics, text analytics. Um, and so we prompted the model, including the CMC Act taxonomy and the politeness coding scheme, along with some other instructions. And we asked the LLMs to state their reasoning also, in addition to giving the codes. And then after that, we compared the LLM output and its reasoning with human coding, and we manually classified differences using a grounded theory approach to classify the differences. And probably you won't be able to see the prompt, but I'm going to click on this and I'll read you a little bit of what the prompt says. So first it starts off saying, you are an annotation assistant for a research project on computer-mediated communication. Your task is to read a single utterance in context and assign the correct communicative act label from the taxonomy developed by Herring, Dawson, Penamarty, 2005, revised in 2024 by Herring and Gostadnik. So it gives the references to the methods. It gives the background story. The utterances come from informal discussions among Reddit users, commenting on a post in a subreddit about, ask me anything, and it talks about the original post. You are shown a target utterance along with its immediate context. These interactions often include sarcasm, support, disagreement, or attempts to clarify, and your job is to label the target utterance accordingly. It then is fed the CMC Act taxonomy and the politeness coding scheme and the meta acts as well, and given some further instructions about the output formatting. Uh, if the user requests reasoning, you must think aloud before labeling. In your reasoning, consider 2 to 3 possible communicative acts, narrow down to the 1 to 2 most plausible labels, test each plausible option against the discourse, select the best fitting label with justification, and then it also summarizes the procedure at the bottom. Number one, read in context, use the prior and next message if available to interpret the target. Number two, one act per utterance, assign only one primary communicative act. Number three, politeness slash meta acts are both optional. Add these only if they are clearly present. And four, the least frequent act is preferred. When in doubt, select the rarer but also fitting label. And these are instructions that are also provided to the students about select the least common act if two could equally apply. So it's a fairly lengthy prompt, and we did massage it a little bit. We gave it some instructions at first, and then it wasn't quite doing what we had hoped, and so we refined it through several iterations. Okay, So then after we get the results from the AI, we compare with the human coding. And the differences were coded according to this coding scheme for the ACT codes. So it could be that the AI's answer was better than the human code. There are a couple cases of that. Or it could be acceptable but not optimal and the reasoning is plausible. So very often, if a student has a different answer or more than one answer could be given, there would be some that would be acceptable, but maybe not the one that we would most prefer. Then we also have acceptable but not optimal, but the reasoning is incorrect in some way, which happens sometimes. Then we have plausible reasoning, but wrong code. So the reasoning seems okay, but then they come to the wrong conclusion. Or you have correct reasoning, but the wrong conclusion and the wrong code. So more incorrect. Or simply wrong. It's just in violation of the ACT taxonomy, and the reasoning doesn't provide a plausible justification. And then the politeness coding, there were three possible categories. The AI could fail to apply a politeness code where one is needed. It could apply a code where none is needed, or it could apply an incorrect code. So the politeness type might be incorrect, but the observation or violation of it is okay, or vice versa. I'm sorry, I did that backwards. So basically, the politeness type could be correct or incorrect, and then the observation or violations could be correct or incorrect, or they could both be wrong. And we haven't finished with all this latter coding. We haven't conducted inter-rater reliability yet. So I'm not going to present any numbers. The numbers that we have so far, I think, are too preliminary. So I'm just going to give you um, some qualitative summary and some examples. This is very much a work in progress. So first of all, as regards the acts, what did the AI do? Well, first of all, we found multiple differences between the AI and the human coding. So it would not achieve an acceptable level of inter-rater reliability. For example, if you set your threshold at 80% agreement, it would not agree 80% of the time. We especially found differences in the coding of the meta acts. However, some of these differences were acceptable. That's maybe not the ones that we chose first, but we could see that it were perfectly reasonable. And other differences, maybe not as good, but not very serious misunderstandings. So very similar in fact to the kinds of errors that these students would make in my CMDA class. And remember, these are sophisticated students. These are mostly actually PhD students, doctoral students, and some master's level students. So they don't make typically really very bad errors. But interestingly, and what I found particularly fascinating is that the reasoning is correct sometimes, even when the code is incorrect. So they have a completely incorrect code, look at the reasoning, and you say, it actually does understand. But somehow it didn't make the connection between that understanding and the application of the code that should reflect that understanding. So that happened quite a bit. Um, we also found that, also perhaps surprisingly, that GPT 4.0, which is the older version, performs better in this task than GPT 03. Basically, GPT 03 over applies less common codes like elaborate or react. Um, even well, and in a way, this is our fault because in the prompt we told it to prefer the least frequent act. When in doubt, select the rarer but fitting label. However, it's interesting that GPT 03 did this, but GPT 4.0 did not over apply the less common codes. So maybe we can say that GPT '03 followed the instructions better. And here's some examples of differences in the ACT coding. So on this chart, we have some utterances from the data sample. We have the human codes, the codes assigned by GPT 4.0 and GPT 03. And then in the leftmost column, there are codes uh, to the classification of the differences. So the least serious differences are lower numbers, the more serious differences are higher numbers. Um, where 6, we would say, is just flat out wrong. 5 is mostly wrong, but maybe there's some little bit of understanding that it's right. So I'm glad you're out now. Humans coded this as a claim. It expresses a subjective feeling of gladness. And both of the AIs coded it as congratulate. So I would consider that this is possible. Congratulate is also an umbrella code, and it could include um, expressions of support, although typically it's more like congratulations on what you did, or I have confidence in your ability to do something. The fact that you're out now was not actually something that the youth it wasn't under his control, right? He was released from jail, but he didn't actually accomplish something. So, maybe not optimal, but we can see it. We can really see why they would have interpreted it this way. And the next example, I'm sorry you went through this. This is an example of what I'm calling a compassionate uh, apology that's not really an apology, right? So this we coded as an apology, a non-bona fide apology. And it's conventionally understood to be supportive. ChatGPT 4.0 just missed the meta act and said it's a flat out apology, which is not right because, of course, this is not a person taking blame for the youths having been in prison. And then GPT-03 coded it as a reaction, which is, I think, an overly broad interpretation of the React code, which is typically just more kind of shorter, neutral, well, shorter reactions of all types, like wow, hey, oh, that sucks, or yikes, things like that. So we thought that was not so good, and particularly the reasoning was not so great. And then we have the last example. Should she never have subjected OP and his sister to this? Yes, they're talking about the mother who didn't stop the boyfriend from doing these things to the younger daughter. Should she never have subjected OP and his sister to this? Yes. So we humans coded this as a claim. The basic claim is she should never have. It's a rhetorical question and a self-answer. She never should have subjected. Uh, GPT 4.0 coded it as a behave, misunderstanding the behave code entirely. The behave code is where the text performs an action, a sort of a performative kind of thing. This is simply reporting on a behavior, so this is just a misunderstanding. And accept is a misunderstanding as well. It just focuses on the yes at the end, but the overall act is not accepting what was said previously. So I can show you some of the reasoning behind these, what I guess we can call incorrect codes. This is the example. I'm sorry you went through this. And this is the reasoning that was provided by GPT-03. It says the target utterance expresses empathy and support toward the original poster. That's correct, right? So possible acts include apologize, that fits the literal I'm sorry, but the definition stresses self-blame or humble self-deprecation. Here, the speaker is not apologizing for something they did. All of that is exactly correct. Then they consider react, shows engagement and emotional response to what was shared, conveys sympathy, solidarity, which aligns with react, positive. This is incorrect. This is not the definition of react in the CMC Act taxonomy. It's hallucinating a little bit here. Then it goes on, given that the speaker is reacting sympathetically rather than apologizing for their own action, all correct, react is the better fit. Incorrect conclusion. Politeness, this is supportive, so plus P. No meta tags needed. So it missed because it didn't code apologize as non-bona fide. It missed the meta tag. So we see how it can seem to understand, but then arrive at the wrong conclusion. In this case, because it correctly understood apologize, but it did not correctly understand react, and it failed to apply the meta act code. Um, What about politeness? So we also found multiple differences from the human coding. Both of the LLMs undercoded minus P, minus N, and plus N politeness acts. Um, and interestingly, only about 40% of the differences were shared by both versions of the LLMs. Um, I'll tell you about what mistakes they made, differences they had with the humans that they had in common in a minute. But one of the main differences between them is that Chat 4.0, GPT 4.0 undercodes plus P. So it undercodes all of the politeness codes. It misses politeness when it is there, when it's relevant. Whereas Chat GPT-03 overcodes plus P. It undercodes everything else, but it's very, very generous. It's very liberal with applying the plus P code. And I would say it's not entirely wrong when in doing that. It's basically a lot of the messages are supportive of the OP for what he went through going to jail. They understand why he killed this man who was abusive towards his family. Um, and so they code them, and anything that expresses support as plus P. We humans did not code all of those as plus P because we took the larger context into account, which is that on these Ask Me Anything posts, it is normal. The default is for people to be supportive, to go easy on the person, the ex-convict, as it were. And so we did not think that many of these were actually explicitly plus P. But I wouldn't say that, that the AI's coding was completely wrong. The shared differences, the differences that they both had with the humans, included what we consider some rather challenging examples because the surface form differs from the pragmatic meaning. But for humans, especially for native English speakers, it is easy enough to understand these examples. And I'll give you a few examples here. These are examples of shared differences in the politeness coding between the two AI versions. So the first example, we have the coding, our coding on the left there. So the first example is a 3A. It's an incorrect application of a code. Uh, what an insult to charge you with murder after what this sack of shit had done. We already saw this example. So in this case, the humans coded this as plus P because the person typing this message is sympathizing with the original poster, with the youth who was incarcerated, that he shouldn't have been charged with murder because the person that he killed was a sack of shit and deserved to be killed, and that he actually had done a good deed by murdering him. So he's very supportive of the OP. However, because the AIs focused on sack of shit, which is an insulting epithet, they both coded it as minus P. Look at the next example. You had to choose between your freedom or allow your sister and mother to continue living in fear. This is an example where we coded this as plus N, acknowledging and respecting the perspective of the addressee, in this case, the original poster, showing understanding for the position. The AIs did not pick up on this. Neither of them did. And then the last example, uh, there just seems to be a large chunk of the story that is glossed over. We coded this as minus P because this was a person, a commenter, who was basically accusing OP of not telling the whole story. In other words, you're leaving something out here that maybe doesn't make you look so good, is the implication. And we got this implication from the larger context. So we coded this minus P, but the large language models did not pick up that this was actually a criticism of OP and therefore a threat to OP's positive face. And I can show you the reasoning here for this last one. Uh, so this is what GPT-03 said for the reasoning. The utterance states that a large chunk of the story is glossed over, implying doubt towards the OP's account and challenging its completeness. This is a disagreement slash challenge. And that's all correct, right? Rather than simply providing information. So it understands that this was a challenge, a disagreement. It therefore fits the reject act, also correct, but it says no clear politeness or meta tags. So it just understands the utterance in some ways, but doesn't understand how it might be face threatening to OP. Okay. So some preliminary takeaways. Um, what we think we are seeing here, first of all, that the LLMs often show understanding through their reasoning, but they don't connect it to the appropriate code assignment. This was something that happened quite a bit. The LLMs sometimes misinterpret um, the intended meaning because they focus on narrow context. So they talk about the preceding and the following context rather than the global context. And the global context is important because you have to look back and be able to see the original post, by the youth. Also, we noticed that the LLMs tend to overfocus on salient words. So, for example, whenever there was profanity, like sack of shit or assholes, then it said, oh, profanity must be minus P. This must be a rejection minus P, even though it is not necessarily used in a minus P or face-threatening way. Also, we had a few examples that ended with LOL, which the AI wanted to code as non-bona fide, even though they were not always non-bona fide. So this is a problem with machine learning in general. Next, LLMs don't recognize politeness. They fail to recognize politeness more often than they miscode it. So it didn't do very well in recognizing politeness, um, except for plus P in the case of the more recent model. And finally, overall, GPT-4o, the general model, seemed to perform better than GPT-03, which is optimized for math and programming, which makes sense. So it's not optimized for language understanding. Some of the broader implications of this study, I think, for CMDA students. So it started off that I was rather concerned that my students were going to cheat by just taking the instructions for the assignment and asking ChatGPT to do the analysis for them. And I wondered how effectively would they be able to do that? And I think the answer is that a student could use ChatGPT and they would probably not get the best grade, but they probably wouldn't fail either. So on the plus side, using GPT could save them time. Also, the reasoning, if they asked for the reasoning, could help the students understand the codes. But on the con side, they could end up getting a not great grade because there are quite a few cases of, well, we won't call them errors, but differences from the human preferences. And the AI could effectively teach incorrect understandings. If the student doesn't have the knowledge to start with, they wouldn't be able to recognize when the AI is wrong. Um, and then there's also, I think, implications for us as CMDA researchers or as researchers of discourse analysis in general, um, because we'd like to be able to use these tools. They allow the coding to scale up on a much larger scale, could be a very efficient way and to save time to analyze large amounts of data. And I also see ways that the AI could improve the CMDA coding scheme. So already, when we've been sort of optimizing the prompt, I've had to explain certain things more explicitly than I had done in the past. And I think that these more explicit explanations, I'll use them in the future with my students as well. And I think that they will help students and others to be able to apply the coding categories more consistently. So I think this exercise improves CMDA itself. On the negative side, the coding quality is imperfect, though. And so any coding that's done by the AI would have to be checked. So I think in the overall takeaway is that both students and researchers should use LLMs for CMDA with caution and check against human understandings. Now I want to talk a little bit about the limitations of this study, and also maybe about the limitations of using AI for CMDA in general. In this study, we only analyzed text. It was asynchronous text. We only analyzed a single thread from a single source on Reddit. We have other threads that we're working on, other Reddit threads that we're working on. And this particular thread, out of all the ones that we've considered, uh, is probably the most straightforward to analyze. So more complicated threads, more multimodal data would obviously pose much greater challenges to the AI. We only used a CMDA approach. There could be other approaches to qualitative discourse that could be used. We only focused on CMC accent politeness. There are other CMDA methods that we want to test as well. Um, and uh, and also we need to acknowledge that some subjectivity is built into CMDA, and particularly built into the coding schemes. And I told you about the areas of the challenges that coders encounter. Those are due in large part to the fact that there is some inbuilt subjectivity in the coding, which on the one hand may have, made it harder for the AI. Also, our prompts, we assumed that the user was not terribly sophisticated from a technological point of view. We tried to imagine the user as being a hypothetical CMDA student, which is to say, probably a graduate student, pretty smart, not necessarily any linguistic background, but also not necessarily tech savvy. Um, and so the prompts that we used we tried to keep them as close as possible to the instructions that I would give the students. Obviously, the prompts could be further refined to improve the AI's performance, and that's something that we want to explore as well. But for this study, we were trying to sort of compare with that hypothetical CMDA student just to see how far they could get if they used CMDA. I mean, if they used AI to perform CMDA. Okay, I don't know. I don't think I have time, and I'd rather save some time for discussion. But if you're interested, I have an example here of what I think might be close to the ultimate challenge for AI to do CMDA on this multimodal, multi-layered example, but I'm going to skip right over it for now and go straight to my uh, conclusions. Obviously, AI is here to stay. It's the future, and it will become better over time. As AI tools develop, they're likely to become more integrated into CMC methodologies and linguistic methodologies, offering new ways to explore and understand discourse and online discourse. And the ease, convenience, and speed of generative AI compared with other methods, especially with manual analysis, is going to attract researchers. Researchers are going to be drawn to it and they're going to want to use it. And when they do use it, I think it will affect how we conduct CMDA and CMC research more generally, and discourse analysis research more generally if it's used for that as well. Um, and what I want to say in conclusion is that while there will undeniably be gains, there will also be losses. What do I mean by losses? What will be lost? Well, generative AI will supplant current natural language processing methods that require programming and computer science skills. And that's a good thing, right? Because that means it will become available to people who don't necessarily have those skills. Traditional, more tedious manual methods, such as the way we've been doing CMDA for all these years, will become less common. CMC researchers will likely spend less time as a result in close exploration of their discourse data. Um, and close exploration of discourse data has a number of benefits. The researcher gets to know the data intimately. It enables small-scaled, nuanced observations that may be overlooked in large-scale analysis, subtle phenomena. Uh, but that could generate crucial insight. And also, close exploration develops observational skills. So So one could, these observational skills could become less developed in the future, and the quality of the research itself could suffer. And so my recommendations for researchers, and that I try to follow myself, are to adopt a mixed methods approach that involves both qualitative and quantitative and computational analysis. That I recommend that always checking the output of the AI, but also spending time with some of your data uh, before and or after automated analysis, looking at it in depth and manually. Um, Also ask yourself, how will I adapt this approach in my research and teaching? And this is something that I've been thinking about a lot, and I've been increasingly incorporating AI into my teaching in other ways. But it's something that needs to be thought about and I think addressed systematically. And with that, I want to leave you with this question. Those of you who do discourse analysis, or some of you may even do computer-mediated communication analysis, will you welcome generative AI? Will you welcome large language models into your CMC or discourse analysis research? And why or why not? And I'd love to hear your thoughts about this. And in concluding here, I just want to thank my research team and show their pictures. Suyun is here, I believe. I don't know if Haining was able to make it, or Yuiru is in China at the moment, so I don't think she will be here. And with that, I thank you very much, and I'm going to stop sharing so that I can look at you.
Thank you very much. Thank you very much, Susan. It was very inspiring. And Miriam Eke, Ilse de Preter had to leave, but they wrote in the chat, thank you, Susan, for this inspiring talk. But sorry to leave, and I definitely share their
Okay.
opinion. So you uh, open floor to a lot of questions, and I will ask the audience if there are questions. I saw in the chat that Asta asked a long question. Asta, maybe you want to read it or just to,
It's just a comment. So if people
yeah,
want to read it, I don't want to take time. Thank you.
okay.
But no, it looks very interesting. Yeah, please do read it.
Asta and then Simo.
Well,
Asta, go ahead.
I'm very fascinated by this. Hello, Susan. It's so great to see you. So we did a similar study, but not with the students. And I think doing it with students is fascinating and very important in thinking how we integrate basically the AI tools into our classroom. So we did an automated kind of analysis by asking humans, media scholars, to rate basically statements about public opinion. And then we did this with the multiple AI tools.
Mhm.
So maybe the results for this, Gemini showed the lowest agreement when we did the intercoder reliability. And for coding, we saw that both humans and machines face challenges in detecting latent content, that is sarcasm, which was the most challenging for both. And
Mhm.
political leaning was more difficult for LLMs.
Mhm.
And humans basically, and for sentiment and emotionality, they're most consistent between. So that's in some ways it was interesting for me that you were analyzing politeness. So that's one of the area that we can talk more about,
Mhm.
whether it's something similar to sentiment analysis and how you treat that. Um,
Mhm.
what would be the differences basically for
Oh,
AI?
between sentiment analysis and politeness. Well, politeness
Yeah.
is much concerned with the face, and so I think sentiment analysis also you need to understand who is the target of a message in order to understand the intended sentiment of it, whether it's positive or negative. Of course, politeness. Um, uh, I'm drawing on the Brown and Levinson paradigm, which distinguishes between positive and negative politeness. So we have these different notions of different kinds of face. I think sentiment is more it's more concerned with the valence of a message, right? You know, sort of positive, negative, or neutral. Whereas with politeness, it's not just simply that some utterances are positive. They can be positive. They can be paying face, observing what I called observations of face. They can be paying face, which would be considered, I guess, a kind of positivity. But they can also be violating face, but they can do it in different ways. So I think it makes this politeness analysis makes distinctions that sentiment analysis
Couldn't.
does not.
Mhm.
Mhm.
Mhm. And my probably a follow-up question to this would be, a real question would be, are you planning or thinking of fine-tuning your prompt? Because you said that in your initial instructions, you know that maybe, when in doubt, please use this code. Would you consider that as a new prompt, or are you planning to do any refinement or changes in the prompting to
So
see what
our
the results would change?
Yes, right. Yes, the answer is yes. So Heining is our prompt engineer. I don't think he's here. And he included everything in a single prompt, right? So we didn't have actually any follow-up prompts. Um, we do want to see another question, really, another study, I think, would be to ask how how well. So right now we're asking, can AI do CMDA? What are the issues with it that we encounter, that a student might encounter? But another question would be, how well can generative AI do CMDA? How using all, whatever skills we might have in prompt engineering and so forth, how accurately can we get the AI to do it? And I think that's a separate study, but we are interested in exploring that as well.
Thank you. Thank you very much. I think that Simo and Eduardo raised their hands. Simo first.
Okay, thank you. Thank you very much. This was very fascinating, exciting. I found it interesting when you said that the reasoning could be correct sometimes, even when the code was incorrect.
Mhm.
So this is related to the previous question. Is it because um, the LLM did not understand the meta language used, the concepts that were used, for example, in the politeness theory? Uh, that was part of the coding. Uh, is it? I mean, it just crossed my mind. Was it because the LLM understood politeness as an ordinary language concept, rather than as a sophisticated, complex concept that has a whole theory behind it? Could this be the reason?
I think that the LLMs do have a tendency to try to default to ordinary language
Okay.
understanding, something we
Yeah.
have observed. Um, but what I would say in response to that, because if that was the case, that they were doing that all the time, then clearly the problem would be with our prompts, right? That we're not giving them enough instruction. But they sometimes do reason correctly and get the right answer. And so that's another thing I should have mentioned that surprised me very much is how inconsistent the LLM could be. That it would apply one code correctly in one context and not apply it correctly in another context. It would reason correctly in one context and not reason correctly in another context with a very similar kind of message. And this is something. So, and Haining, who is our prompt engineer, has explained this in a way that I'm probably not able to fully explain it to you, but he says it has something to do with the fact that the AI is responding conditionally. And so part of the conditions are the immediately preceding and the immediately following messages, which are, different in each case. And so somehow that overrides uh, reference to the coding schemes. But sometimes it makes very explicit reference to the coding schemes. It says, I coded this as a greeting because we have an example in the coding scheme of a greeting that looks very much like this. So it
Right.
clearly has access to the coding schemes.
Okay.
It just doesn't consistently apply them.
Okay. Thank you very much.
Yeah.
Thank you. So, Eduardo?
Yes, first of all, thank you very, very much for the extremely interesting talk. I would try to answer your question, your final question about would you or would you not use it? And I hope that it can be useful. Perhaps I could convert your question into an equivalent, that is, why use it? For which purposes? And in my opinion, the reason to use it in many fields, including discourse analysis or computer-mediated discourse analysis, is to do quantitative research, or quantitative, perhaps. Is that the right stress? Quantitative research. Because essentially we process information much slower than at light speed, while obviously these tools do it at light speed. So if you want to do quantitative research, you can benefit from speed, and you could decide that you sacrifice accuracy to speed, provided that the cons are less than the pros. And this is probably already true, and if prompts are built correctly and cleverly, then even more so. So I think for quantitative research, it is obviously a good perspective. I would obviously use it. Then personally, I'm not particularly interested in quantitative research, perhaps because of my age. I have seen quantitative research reducing the space allowed to good ideas in many fields of research. So let's switch to qualitative research. In case you want to do qualitative research, I think that almost by definition, I wouldn't use a large language model wouldn't be useful, because the categories to be inquired are not real, objective, out there existing things. They are something we decide to postulate as relevant. So it is impossible that someone can assess the presence or absence of such categories better than myself. That is, better than the researcher who has built, conceived of, defined those categories.
Yes.
So
Indeed.
if it is not quantitative, if it's just qualitative, the best thing an artifact can do is be as good as me, but that is very, very unlikely. So I would draw this boundary. Yes, for quantitative, no for qualitative research.
Interesting. Thank you very much for sharing that perspective. I would point out that there are a few examples, though, where we have been quite impressed. And, Suyang could maybe comment, although, yes, you're still there, where we've been quite impressed with the AI, and even where we have changed our coding, our understanding, because we think the AI actually had a better answer. And I do wonder, as the technologies become more and more sophisticated in the future, if they might not be teaching us things. So I think that's a potential benefit as well. But as somebody who does count things sometimes, I feel ambivalent actually about quantitative research for CMDA, because I've never felt the urge to do massive, large-scale analyses, because I feel like you couldn't possibly know your data well enough to be confident about your conclusions. You have to be able to look at the data and get to know it. But there are people doing very interesting CMDA work on a large scale. Let me see if I can remember his name. Christian Danescu Mizil. I think I'm leaving out one of his last names. At Cornell University, as a young researcher who's been using machine learning in very creative ways to analyze CMDA kinds of problems, including politeness in online discourse, online forums. So I see a potential there for CMDA to expand. And the whole point of the paradigm is that it's not one single method. It's not one single approach. You can apply a variety of different approaches. These two happen to be similar in a number of respects because they are meaning-based. They involve meaning. They involve a certain component of interpretive subjectivity, which is why when humans do them, I always recommend that you do inter-rater reliability assessment because of that potential subjectivity. But there are other CMDA methods that lend themselves better to quantification, and others that lend themselves even less. So there's a whole spectrum of approaches, and I have thought for a long time that it would be good to add quantitative approaches to the toolkit. The question is how, for me, is how best to do that. And this is what we're starting to explore this now with generative AI. But I'm curious about other people's reactions too, about whether you yourself personally would use large language models in your research,
Any reactions?
or whether you do already.
Any reactions? People who want to tell an experience? Judith.
Thank you very much, Susan. I'm mostly impressed by your work and your presentation. Are you already working on, I was wondering on the use of examples generated by artificial intelligence, basically working on what they produce themselves, and before the code assignment evaluation, in order to maybe identify patterns of inconsistency and patterns of unreliability. So which are the ways in which you understand how they rank the coding scheme? Have you already worked on asking to invent examples before coding? And maybe for teaching related purposes, how could we ask students to teach ChatGPT? Of course, I'm sure this is done already, but invert the roles in a way as if they were the learners.
I have not done that. Although the ability of generative AI to create examples is something that has been mentioned in the literature as a potential advantage, particularly for people who maybe want to do psycholinguistic analysis and want to create hypothetical data sets to use in experiments, for example. So generate me examples that have these characteristics. So in an experiment, you might want to control those characteristics so you can get the LLM to generate data for you that is like the kinds of data you're interested, but maybe protects people. It's not violating anybody's privacy. It's not using their real data. These are all manufactured data, but they have certain characteristics that we wanted to have for the purposes of our research. I don't do that kind of research myself, so I haven't done that yet, but it's something that I think is intriguing as another potential application.
Yeah, I was thinking of the coding assignment for politeness, see what they come up with to flesh out how they code consequently. Thank you very much.
Yes, thank you.
Any other reactions, questions, experience?
Yeah, experience. Anybody else
I do have something. For example, we used in our class with a colleague who is not here, is a research scholar from Nanterre, Paris. Among other techniques, ChatGPT to annotate excessive discourse. And we used it asking ChatGPT just to produce examples of excessiveness at various levels of linguistic analysis from a zero-shot perspective. So please tell us what is excessive at the phonetic level, at the phonological level, at the prosodic level, at the syntactic level, and so on. And we use it so we tested it in the classroom. We had I think 15 computers asking the same question, the same version of ChatGPT at exactly the same time with exactly the same phrasing. And we got 15 different answers. These answers were not scientifically reliable, but they inspired us a lot because we had not thought of certain markers of excessivity, which were
Right.
quite pertinent. So in a sense, we used this experience just to create the ground, to pave the ground for our own annotation scheme. In a kind of incremental, procedure. What is extremely interesting, and I will make a connection with what Simo was saying about the ordinary language, is that what we notice is that ChatGPT uses an ordinary meta language. So she, he, I don't know. For me, it's a she in any case. For she does, ChatGPT, how do know the genre attribution to this machine. She does linguistics with popular, with ordinary categories, meta-linguistic categories, which could be a benefit for the linguist to relearn, because it could reduce the gap between the community of linguists and ordinary people who have their own metalinguistic representation of their own language. So, for example, why should we talk about gestuality when we can use gestures? So we had a lot of examples, and with our students we try to do this inverse process, going back to the ordinary meta language, which was quite interesting. The other thing that I think we should understand is the notion of perception, because when you use this machine, you understand that there is no the mirror condition, mirror position between what is produced and what is perceived. And you made some examples of something that could be considered as a personal, face threatening, non-face threatening at a certain at the time zero, and could became face threatening 1 year later when, for example, the family of the murderer could read the chat. So we don't know. And when we annotate, what is the perspective that we have? The perspective of the speaker, the perspective of the person who receives the message, the perspective of the machine. So I think that using this machine can raise a lot of epistemological questions that can help to do our work even better, maybe. What do you
Yeah,
think?
it's really interesting. What is the machine's perspective, right? Just even thinking about the different levels of interpretation that I talked about, this surface level versus the conventional level versus the discourse condition level versus the psychological level, the machine seems to oftentimes focus on the surface, as we might expect, but not always. And it tends to overinterpret based on sort of more general, maybe natural language, natural social interactional norms. So a lot of times it'll say, well, this message, you can tell they're being supportive. Well, yes, maybe they're being in general they're being supportive, but there's something more specific going on. So it tends to prefer the more general, I think, is one of the kinds of errors, if you will, that it makes, one of the ways that it differs from our human coding. What I actually find very fascinating too is what you said about how you got different results, all different results, asking the same question of the same model. And that variability, that inconsistency of the machine really intrigues me, uh, because this is not how we think of computers, right? We always thought one of the advantages of doing computational analysis is that the computer is always going to do it the same way every time. And therefore you could get around human inconsistency, human variability. But in this case, the humans are actually more consistent than the machine. And what do you do with that, right? If you know that, I mean, it's important to know that the machine can do that, and therefore that you cannot assume that the answer that you have today is the answer that you're going to get tomorrow, or in a second from now. How do you use that information? Can you maybe you decide you like a particular answer, so you accept that one, but then you get another answer. Do you keep asking it until you get
We created a sheet form with all the questions, with all the answers, and we compared the answers just to change the category of some answers, exclude some answers, keep some of them. So it was an exercise from a pedagogical point of view for the class, just to work on these categories and with different levels of analysis. But it helped a lot in the sense that we hadn't thought of a lot of the markers the AI suggested. So we made a critical analysis of the results, a comparative analysis. Yeah, that's what you were suggesting at the conclusions of your talk. So it was just a prompt for us. I mean, just to do our
And
analysis.
that is one of the ways that I think that AI can be used most effectively, is to help generate ideas, right? To generate insights that the humans can then refine. It still leaves open the question of, how can we use it to scale up to, large scale analyses? Can we trust it? How much can we trust it? I think is a big question. And I think that question is not answered at this point, but it's going to get better. And that's why I presented the concern at the end. When it gets better, when it gets very, very good, so that it can do all of these analyses and agree with our codes, let's just say, agree with itself and agree with human coders, let's just say it achieves that. There's still that what is lost when the humans are no longer
Of course.
deeply immersed in the data.
Of course, I agree. Yeah. So let's thanks again, Susan, and all of you for your participation. Thank you very much, Susan, for your time, and I think that you will have a nice. I wish you a beautiful day. I mean, we are going in Europe just to have our dinner and night, but you start your day, right?
I am, and today is actually a special day because I am having a birthday party. I am turning 70 years old.
Oh, happy birthday.
Happy birthday.
So that was a special time that you dedicated to us. So thank you. Even better. Okay, thank you very much. Happy birthday. Have a nice day, and thank you all for
Thank
being
you.
here.
Have a nice night, all of you.
Thank you, Caroline.
Ciao, ciao, ciao.
Bye bye.
Thank
Bye.
you. Bye.
Bye.